all these network issues and various other challenges that we are facing. I hope with the advancement in communication technology and with the advancement of 5G networks, we will not have these many network issues going forward. Now, just for you to quickly see who you are speaking to, I'll just turn on my video briefly so that you can see my face. This is Shrikant, and I will turn off my video right now to ensure that we don't have bandwidth issues. Okay, so now let's get started and let's get into the sensors, smart sensors, and the role of Industry 4.0. The basic agenda that we will be following today is the differences between the BPCS and safety instrumented system, change in mindset that people have in order to move from centralized architecture to federated architecture. What are these two architectures? We will understand. Then we will understand what is Industry 4.0 basics and what are the pillars of Industry 4.0. How is data science acting as a prime mover for Industry 4.0? The concept of sensors or the role of sensors in Industry 4.0. Mainly when we look at sensors and control systems that we have in traditional plants, how they are going to change with respect to Industry 4.0 concepts. And then we will get into the challenges that we have with respect to cybersecurity and the tools and techniques which everybody must have in order to excel in this particular area. So without further delay, let's get started with what is a basic process control system and how it is different from a safety instrumented system. So when you're looking at any process plant, you have got a sensor, a plant, and an actuator. The basic process control system takes inputs from the sensors, applies a transformation, and drives the actuators based on it. Now, a BPCS is typically used in places where safety is not a major concern. For example, if we are having a low critical application, like for example, mixing of two components A and B at optimum temperature such that the mixture itself is not hazardous or the mixture itself is not flammable and it does not cause any threat to the human life, then we can use a BPCS. Now, what happens in case the system is operating on some hazardous equipments? Simple example that we can think of is a steam or a heat exchanger. Here we are dealing with water which is getting converted into superheated steam and it is going out of the control system. Now, in case there is a leak that happens in this entire plant somewhere, either the inflow of cold water is reducing or the outflow of steam is reducing, then the entire plant is a potential atom bomb. It can burst open and cause lot of fatalities and lot of human life which can get lost in this process. So for such systems, we augment this BPCS using safety sensors and we call them as safety instrumented systems. Now, what is the difference between a BPCS and a safety instrumented system? Along with the sensors that we have got in the plant, we have got a bunch of safety sensors which do redundant monitoring of these sensors. And in case they find that this plant is going out of control, then it manually does an override and shuts off the plant to avoid any hazard. Now, if we look at the flow with respect to the BPCS and a safety instrumented system, we have got a basic design and basic control system, which these two circles contribute to the BPCS. Later on, whatever we see here is a part of safety instrumented system. Alarms and manual intervention, automated safety, where we have overrides of systems so that the entire system can actually be taken into a safe state. Physical protection of the assets. It could be human assets, it could be resources, it could be the company assets, or it could be environment. In case an accident does happen, how do we tackle this particular accident? How do we call the community response? How do we get the fire engine and ambulance on board? They come as a part of the emergency response team. Further, the last part that we are dealing with in a safety instrumented system is called as community response. In case there is a hazard which has happened and it is potentially causing a danger to the people living in the neighborhood, then what kind of action do we need to take? As we see here, as the level of safety keeps on increasing, the gravity of the situation that we are dealing with is also increasing. Initially, if there's a very minor change in the system, an alarm can be activated, thereby a human being can come and take the system back into normal operating mode. For example, he can identify what is happening in the system, correct that system, and ensure that we have zero downtime or close to zero downtime. In case the system is still going out of control and it's becoming difficult, or it is not possible for a human being to control the system at this point in time, we go into automated safety. This is called as the level 3 of safety, where the first level of safety is basically alarms and manual intervention. The second level would be the automated safety, where it does an override of the system. The final level which we think of is the moment we do an override and we are able to bring the plant back into control. Still, we do have a downtime. We do have time to actually get the plant back into operation, but then we are looking into the physical safety of the assets and the human beings that are present. From this point onwards, we are actually thinking of loss of life or damage to the environment. Things become more and more serious as we go higher above in the safety instrumented system. Now, when we look at the layers of protection that we have got, first of all, if we are looking at a simple heat exchanger as an example, the failure modes that we can think of is decrease in inflow of cold water, which would mean increase in the steam pressure. That would mean increase in the flow, outlet flow, which can potentially cause a damage or potentially cause a hazard. Now, given that we have got a problem and we need to address this particular problem, we can add a layer of protection, which potentially could mean bypass your exhaust valve to have a pressure let out in case the pressure buildup is quite high. Now, when we look at these layers of protection that we are speaking of, I'm sure Krishna sir will be speaking about this in much more detail when he covers the safety instrumented systems and when he covers the layer of protection and the LOPA analysis that we specifically do when it comes to safety. I'll just give it to you in a very brief nutshell. He will be covering it in much more detail. If we are looking at the layers of protection, there are multiple layers in which we can think of, and each layer has a cost associated with it. The last step that we do in the safety instrumented system design is called ALARP, ALARP, which is basically finding out what is the minimum that we can do in order to achieve the safety of this system without compromising any loss of life, damage to the environment, or to the company assets. So after all these are implemented, there is another very important layer called active or passive safety protection. Now, what is the difference between active safety and passive safety? Active safety is the protection that we are able to take care in our safety instrumented system before an accident happens. Anything before an accident happening is, if we are able to control it or contain it, then it is called as active safety system. Passive safety is used when an accident has occurred and the system is already damaged. Now, there are two things that can happen when an accident has occurred. First thing that we need to ensure at that point in time is protection of human life. So the passive safety will mainly focus on protection of human life and further avoiding a cascade disaster to happen. Active safety is avoidance of an accident, whereas passive safety is protection of human life after an accident. Now, given that we have got either an active safety or a passive safety protection, the plant can get into an emergency system where it goes into a emergency response. Let us summarize what we have. What are the differences between a BPCS and a safety instrumented system? First thing, a standard BPCS has got unknown failures because we are not really worried about a failure in such a system. It might not cause a big hazard to human life. Of course, I'm not denying the fact that if a system fails, we will get into productivity loss, we will get into manufacturing losses, and thereby it leads to loss in profits in a particular organization. But it does not cause loss of life. So that is what we are looking at when it comes to the differences with respect to BPCS and CIS. Safety instrumented PLC, on the other hand, need to fail. Even if it fails, it needs to fail in a safe way. Safety instrumented system need to meet certain standards like IEC 61508, and they must be configured by a person who has the right competency. Okay, now we have understood what is the difference between a BPCS and safety instrumented system. Now, this entire traditional approach that we are using with is the entire approach that we are actually using. What do we mean when we say that it's undergoing a paradigm shift? Let us take a simple control system or a plant which is present in a particular place. It has a set of sensors, it has some localized control and a set of actuators. With the localized control, what we cannot do is we cannot achieve more from the same plant. On the other hand, if I have local offices which are taking control of certain decisions, certain supervisory decisions are taken care by the local offices, and the key decisions are transferred to the headquarters for taking certain critical decisions. In this case, what's really happening is the local offices are authorized to take decisions under their purview, and the headquarters is capable of taking certain decisions which can override the local office decision, or it can add on to the local office decisions. So the differences between centralized control and distributed control is, in a centralized control, you have everything in place in-house, and you have got a plant which is actually working in a self-contained environment. It is not really connected to the outside world. It is only connected to the headquarters where they are actually dealing with, and the headquarters takes a decision to drive supervisory control on to the target plant that we are dealing. Now, if this operation gets shifted to a distributed control, as we see here, we can get local expertise for a particular functionality, get that implemented by the experts present in a given area, transfer the outputs that we have got to the headquarters, and supervisory decisions are taken here in the headquarters. Now, what benefits does this bring? We are able to divide the work among multiple people. We are able to apply advanced algorithm at the local site, giving authority to the local people to use discrete powers which they have got, limited to the guidance as controlled by the headquarters, and driving your outputs based on the commands which are coming from either the headquarters or the local offices. By this, we have actually got into a benefit situation where we can get the implementation done by people who are local experts. Now, how we are converting this concept of distributed development into a smart industry? It's quite simple. If we are able to implement connectivity to all the BPCS that we have got, and if all the systems are able to speak and interact among themselves and take decisions not only based on their localized inputs, but based on the environment from outside, then we are able to say that these industries are able to speak among themselves and take a better decision rather than working on their own. There is a very classical proverb in English where they say that if you want to go fast, walk alone, but if you want to go far, go with a friend. It's exactly similar here in a process plant. If you want to do something very, very specific and in a given span of time, it is better to implement a BPCS. Whereas if you want to go far and if you want to do something smart, then it's better to walk along with your friends. And who are these friends? All the friends, all the friends are available as sensors and actuators connected over the internet. So by connecting systems over the internet, you are able to do distributed development, change of responsibilities and roles across the people who are specialists in a particular field, communication over Ethernet or any other uh, networking medium, and supervisory decisions taken by the headquarters. So now we see that we are able to migrate from a BPCS to a smart industry. And this is called Industrial Revolution 4.0. In short, it's called Industry 4.0. Let's try to get into this and try to understand what really caused this Industry 4.0 and how is this evolution happening. First of all, people were all hunter-gatherers. They were present in forest, and the only thing that they had to do in the forest was to protect themselves against wild animals, hunt or uh, figure out the sources of food, eat their food, and stay happy. They were always living in fear, and they always wanted to find out easy ways of doing their work. That is when one of these hunters discovered what is known as the mother of all inventions, and that invention is nothing but the wheel. He found out that instead of walking a long distance in a forest, what if I find out something which can actually take me to that place without me putting some effort? Those days, for sure, there were no concepts of Newton's first law, second law, or concept of momentum, which was known to this person. But he knew that if I am able to put a plank on two wheels and the wheel is able to move on its own, because of whatever reason, I am able to reach my destination at a faster rate. This was the initial thought process for this hunter gatherer to get into industrial revolution. This was the first set where industrial revolution started. We can call it industry 0.0, where the person was able to do some good work by putting minimal effort. Now comes industry 1.0, where they found out that, you know what, if we actually let this hunter do all the work himself, then it's not going to help us. So let's divide the work into 2 or 3 people, where we make one person develop certain tools like a hammer or a sword or some tools which can be used to kill an animal. And in return, another person uses this tool and kills 2 animals. He eats one animal himself and gives another animal to a person who made this tool. So the early days Stone Age people were still doing divide and conquer. They were able to divide work among themselves and go and satisfy their needs. This was Industry 1.0, where there was a lot of mechanized work. People were working in shifts. They were working with mechanical systems in order to achieve a common goal. Later on, they found out that, you know what, we are all struggling. For example, as a person who is making this tool, I need to keep beating this hot iron in order to convert it into a sharp knife. And the person who is actually the hunter, he feels that he needs to take this knife and go search for an animal to kill it. Both are actually causing a lot of work. Why don't we automate this and reduce the work that we are actually doing? So from industry 1.0, we got into industry 2.0, where mass production and assembly lines were the need of the hour. Mechanical systems slowly got replaced with electrical systems, and electrical technology started actually working, motors started working, things started moving without the human being actually moving. This was actually a very, very good era of industrial evolution where things started becoming automated. Now, when we go into industry 3.0, that is when a person felt, you know what, why should I go stand in front of a plant and press a few buttons? Can I let a computer do my work? And let me sit in a room which is air conditioned and I monitor this from a distance. Automation, computers, electronics, they took a significant role in industry 3.0. Now with industry 4.0, what's really happening? This man who was sitting comfortably in the office with a computer now thought, why am I actually working after all? Can I not let the computer learn what I normally do on an everyday, day-to-day basis and let it do what I already do? Instead of a human being actually doing the work, why not let the robotic system start taking over and do the work? There is actually an interesting joke where they say that the future companies will have 3 employees. There will only be 3 employees. The first employee is a human being, the second employee is a dog, and the third employee is a robot. Now you might be wondering, what is a dog doing in this particular industry 4.0 situation? The dog is responsible to entertain the human being and play with the human being. The human being is supposed to manage this dog. The robot is going to do everything else. You know, when a human being is actually not having anything to do, he will feel, he will feel idle, and idle mind is a devil's workshop. So a devil can actually do destructive work. That is why they told that let this person play with a dog and let's have only 3 employees in the company, a robot which does the work, a man and a dog which play with each other through the entire day and go back home in the evening. Yes, we are heading into such a situation with Industry 4.0. Now, with Industry 4.0, what is really happening? Apart from systems being connected locally, we are now calling them cyber physical systems. The name itself is quite confusing. Cyber physical. What do we mean by cyber physical? Anything that is virtual or not even visible to the human being. It is somewhere present, but we don't know where it is. For example, when we are sending an email, do we know through which all servers does this data go through before it reaches the person's inbox? We absolutely have no idea. The entire data is traveling through some virtual cloud, virtual connectivity, and reaching the destination. How is it all possible? Because the entire system is connected through a network. So Industry 4.0 is all about cyber physical systems connected to a network, and the word that we use for all these things connected to a network is called Internet of Things. So let's look at the revolution that we have got. I am sure as senior faculty and staff members, you might have seen these fancy gadgets which will now be seen in a museum. I am sure if we ask our child or grandchild what these are, they will actually stare at it and they will think it's a toy. They will not know the absolute use of this. In fact, there was a very interesting research done in the US where they took the current generation's people who are 19 or 20 years old and they asked them to turn on a Windows 95 computer. First of all, they had a big CPU box and a monitor, and they told, this is a computer, turn it on. You should see the expression in the child's face. The child is around 20, 25 years. They don't know what is the power button, how to turn it on. Okay, with great difficulty, and after turning on the CPU, they also know that they need to turn on the monitor. When they turned on the monitor, they heard a crackling sound, which was actually the relay switching. You know, when we have the old CRT monitors, when it turns on, it makes a loud noise. And then the entire fan in the system started making noise. It looked quite scary, and the students were actually literally getting up from their chair saying that, something has happened. Once the system booted up, the first thing that they wanted to do was to connect to the internet. And the second challenge or the task given to the students was to connect to the internet. First thing they were searching for is, what is the Wi-Fi password for this? The answer which the person told was, this system does not have a Wi-Fi. Okay, then they started searching for Ethernet cable. They told that this system does not have an Ethernet cable either. You need to use a dial-up modem and use a telephone line to actually connect to the internet. And they used a service called America Online, AOL, which was very, very famous those days. The entire video is around 15 to 20 minutes, where you can see all kinds of expressions which the student makes when they are actually looking at a Windows 95 system. And the last part was the funny bit, where they actually asked them to shut down the system. When they shut down the system, they were just looking at the system shutting down. And finally, there was a message displayed on the computer. It is now safe to turn off your computer. When they read that statement, they were all shocked. They asked the question, is it not safe to turn it off when actually I press the button? Or when it was shutting down, what happened if I turned off the power? Will my system go and be destroyed? They were very, very interesting questions that were actually asked by those students. Now, look at what the student is actually exposed to. The day he gets up, the morning he gets up at 6 o'clock or 8 o'clock, these days no one gets up at 6 o'clock, the first thing that he does is to look at how many WhatsApp messages he has got. How many people have liked his Facebook post which he has posted yesterday night. Next thing that he does is turn on all the gadgets using his mobile phone. And once he does all that, lazily he goes to the bathroom to start brushing his teeth. The moment he finishes brushing his teeth, his hot water is ready for the bath. The coffee machine has already brewed a strong cup of coffee for him, and everything is ready when he really needs it. This is called as a smart system. Let's look at how things changed over time. If you look at the traditional telephone, it took 75 years to get the first 100 million customers. Internet took 7 years, Facebook took 4 years, but Pokemon Go, this game, just took 1 month to reach 100 million customers. Now let's just switch from months to days. Just look at this fun. How many downloads really happened in 10 days when we had the first lockdown? You can see that the Zoom app was almost downloaded 14 million times in less than 10 days. We are speaking of months here. Now months became days, and very soon these days are going to become hours. For example, we have a YouTubers who upload their vlogs daily. There are many standard YouTubers who get a million views and almost a million likes in just a few hours. It's as good as a person having nothing to do, waiting for this YouTuber to just post his vlog, so that they can immediately look at the vlog, like it, subscribe it, do whatever they need to it. This is the trend that we are heading to these days. Now, let us look at what is it in the context of Industry 4.0. A traditional system. First of all, what is Industry 4.0? It is a collective term of technologies and concepts of value chain organization based on technological concept of cyber physical system, the Internet of Things, and Internet of Services. It facilitates the vision of smart factory. for sure, none of us would have understood what is Industry 4.0. Industry 4.0 is not a technology. Industry 4.0 is not an architecture. It is just a collection of things working together in order to achieve a particular goal. What are the collection of things? The things are cyber physical systems, which are located at different places in the universe, Internet of Things, each of these things connected to the network, Internet of Services, which are a set of services provided by the service industries. For example, the services provided by Amazon.com or the services provided by Google. All those are specific services which are provided by different people. Now, I do hear that there are people complaining that they are not able to hear the audio. Is from my side, my mic is working well and
No, no,
my
sir.
audio seems to be
You
working.
are getting, you are getting. You continue,
Okay,
sir.
great. Okay, excellent. So now, what do we
Everything is
understand?
good. Everything is good, sir. Everything is going right.
Thank you, sir. Thank you. Okay, great. So let's go forward and try to understand what is Industry 4.0 after all. As we told, it is nothing but a set of terms. And what are the terms that we are really critical of? Cyber physical systems, Internet of Things, Internet of Services. What do we mean by Internet of Services? Let's just take an example. Suppose I have a computer where I have installed a Linux operating system. Okay. And in case I have a Linux operating system and I really want to type a Word document or I want to type a letter, obviously I have not installed Microsoft Word. What do? I blindly go to Google. I open Google Docs. Google Docs provides me a Word document where I can exactly type out my letter what I want, and even better, save it as a Word document which can be opened in Microsoft Word by the person who received it. So look, this service is provided by a company called Google through their services called Google Docs, which I, as a user, I am using. I do not need to be an expert in Microsoft in order to use this tool, nor do I need an installation in my computer to use this tool. So, Internet of Things is all about the thing which is actually providing us some useful work, and Internet of Services are the services which are required in order to make me achieve my goal. And the best fun part of this entire system is they are all located virtually somewhere in the world, and I have no clues where they are physically located. This is Industry 4.0. Welcome to a new world where we are going to walk blindfolded, still reach our destination without any issue. Let's take a classic example of how we lived our days. I'm sure all the faculty here would have gone through the same pain. When we did our project for engineering way back in 1999, we did not have any internet services available at all. I studied in Hassan and there were no internet services available. They used to download all the web pages, and the computer institutes used to run something known as simulated internet. It was a 6 months course called Simulated Internet, where they will actually teach us how to click on Google and how to open a Gmail account using simulation. We did not have internet at all in Hassan. And the fun part was, in case I need to purchase a sensor or I need to find out a chip that I need to purchase, I had to run to the library first. In the library, there was a book called IC Masters. And trust me, the book was heavier than me. First thing, I need to go lift that book. That was the first challenge. Second thing, search whatever IC that I need from that book. It had around 15,000 odd pages. Figure out the part number, look at the data sheet, look at the characteristic curves of it, write all those in my notebook because I cannot actually go back to the library in the night at 12 o'clock and refer that. then come back, run from there to Bangalore, go to SP Road and show him I need this particular part number. The fun part is sometimes I used to get that part. Sometimes he will say, I do not have this part. You tell me an alternate for this. Even more fun, he used to give me the IC master book and he used to say, sit in one corner here, find out the equivalent part of it and let me know. I will see if I have it. Nowadays, if you want to design a power supply, just ask a small kid, a third standard kid. Just tell him that, you know what, I want to design a power supply. The first thing that he will do is unlock the mobile phone and he will utter a magic word. Okay, Google, how to design a power supply. And trust me, within a few seconds, he will get a YouTube video and he will say, look, this is how you design a power supply. And there is something called as LT Spice, which is available online. I can drag and drop all the components. Look at how my system works. And if it works well, then I actually send this circuits to somebody who will actually convert it into a PCB and somebody else will go purchase these components from SP Road. I will assemble them and trust me, this power supply is going to work. Just look at how this guy designed his power supply. He has no idea about a transistor or a diode. He has no idea about a transformer. He just said, okay, Google, how to design a power supply. A YouTube video came. He blindly selected all those components, opened LT Spice, looked at a pattern which matches a transistor. He dragged and dropped those components. Trust me, he has no idea about whether it is used in common emitter or common collector or common base. He had no idea, dragged it, dropped it, dragged an oscilloscope and said, look, this is what I get from a power supply. And then got it fabricated and said, I designed this power supply. I have no idea with what authority he told he designed the power supply. It was the OK Google, which helped him search what it is. Second thing, it was the YouTube video that told him what he needs to do. Third thing, it was a reference model given by LT Spice, which actually helped him to pull out all the components and make a power supply. And finally, what this guy did, I designed this power supply. This is Industry 4.0. Welcome to the new world. What is there in Industry 4.0? Man, machine, and robots, they coexist. Man is becoming more and more weak with respect to his intellect. The robot is becoming more and more clever. Distributed development across multiple sites, connected system. This is what is Industry 4.0. And this is where we are heading to. Now, okay, I've just jumped to the last slide for some good or bad reasons. So let's go to the main pillars of Industry 4.0. Now we all know what is Industry 4.0 and what should be the pillars. Cybersecurity, safety, communication, distributed development. Absolutely no doubts in this. Now, let us see how an embedded system is going to take part in this entire journey of being a cyber physical system and all the way until a smart industry. First thing is smart connection level. In typical instrumentation, what we really say, we will say sensing block. This block would be called as sensors. And when I say sensors, we would be thinking of thermistor, a thermocouple, or an RTD, which is a dumb sensor which gives me a raw voltage of the actual scene which it is seeing. This is going to be replaced with what is called as a smart sensor. What is the beauty of a smart sensor? First of all, it is a plug and play device. It can be connected using Ethernet, Wi-Fi, Zigbee, Bluetooth, whatever way. It is able to connect itself with the network. Next thing what it can do is it is not dumb. It is smart. The name itself says that it's a smart sensor. Now, what do we mean by smart? And what do we mean by dumb? Let's suppose we ask a child to arrange the alphabets in ascending order, and we just throw a few characters A, Q, B, J. Now the child uses the knowledge that it has got and identifies the letters which needs to be arranged in ascending order, and then says, you know what, I have arranged all these letters in ascending order, have a look. That is smartness. On the other hand, if I ask, just give me a bunch of letters, if you go and pick a bag which has got letters distributed in it, you just take those letters and throw it on the table. That is a dumb sensor. A dumb sensor is not able to make any decision. A smart sensor, on the other hand, is able to make supervisory decisions on its own. Let's get into these smart sensors a little bit more detail in the subsequent slides that we are dealing with. Now, the information, there is a small difference here. We need to understand the terminologies quite well. That's why I'm spending a lot of time in this particular slide. First thing, a dumb sensor gave you data. With this data, we can make absolutely no sense unless the data is converted to information. There's a big difference between data and information. Suppose I just keep an apple on the table and a person is looking at it. What he really looks at from the data is there is some circular object placed on the table. That is data. This circular object present on a table is called an apple. Now this data got converted into what is known as information. The moment the data got converted into information, this human being knows that this apple is not present on the table for fun. It is present on the table for me to eat and get some energy. Look how we converted data into information and started making useful decisions or taking useful decisions out of it. On the other hand, a dumb data would be useless and it would just be a circular object present on a table. Now that we have converted this data into an information, we need to send it to the other level. What is the other level? It's called as the cyber level. Let's take the same example of an apple placed on a table and a small child is actually looking at it. First thing, the child is smart because they are born with a mobile phone these days. The first thing that actually a child sees is not their mother. It is a selfie image of themselves with their mother. It sees a mobile phone before seeing its actual mother. This is the fact that we are dealing with in this situation. This child has now converted the data or the apple on the table into information. Then what it does, it goes and asks its mother, can I eat this apple? Look, the data got transferred from one level to a higher level. Next, at the cyber level, it goes into something known as cognition level or taking decisions. This is the most important level where supervisory decisions are taken. For example, if we take the same example of an apple, if a child asks the question, can I eat this apple? And then it physically goes and touches the apple and figures out that it's actually a plastic apple. The cognition kicks in and says, you're not supposed to eat this apple. It is dangerous if you eat it. And the final level is the most important level. Self-configure, self-adjust, and self-optimize. Now look at the beauty of this plastic apple. If suppose I have placed a plastic apple on the table, the child on day 0 looks at that, knows that it's an apple, converted data to information, does the cyber level where it transfers the data to a higher level source to figure out whether it can be eaten. The higher level actually says it's a plastic apple, don't eat it. Now the human being or this child has configured its body again, saying that if I see this apple again in my life, I'm not supposed to use it. I'm supposed to just look at it, clap my hands and move on in life. It is going to be a plastic apple and it is danger to use. Okay. Now look at what we have done in the configuration level. In the configuration level, we are able to self-adjust whatever we are doing, and this self-adjustment makes us do things better as we go. Now, let's get into the details of how a dumb sensor is becoming a smart sensor. I've given you a classic example of a level sensor here, where we have got three different levels that we are actually sensing. Tank is full, tank is empty, or tank is half empty. It is going to give you a voltage level or whatever. It could be a digital switch giving you half full, half empty, or full. This is a dumb sensor. It does nothing but provide data. Now, is a dumb sensor useless? No. Anything in the world and everything in the world starts with a dumb sensor. This dumb sensor is now sending the data to a controller or a detector. Look what this detector can do. First of all, it converts data into information. If suppose I get a voltage level which is say 3 volts, the sensor is giving me a raw data called 3 volts. The smart sensor converts that 3 volts into information which a human being can understand, that is, the tank is half full. Further, what it can do? It can take supervisory decisions. Turn on the motor when the tank is half full so that the tank remains full. Without the intervention of a main controller, this smart sensor itself took the decision. Second thing, what it can do? It can find out whether the sensor is undergoing end of life, whether the sensor needs to be recalibrated, whether the sensor needs to be replaced. It can indicate to the user by glowing some lights here. If you see a red color light, as I've just pointed my cursor here, it would indicate to the user that there is something dangerous happening in your system. Please go and replace it or rectify it before it causes a safety hazard. Now look, we have converted data into information, and it's all summarized here. What really happened when we converted a data into information? In data, there was no value added services. It was dumb numbers. Now, the moment data is converted into information, we are able to make some meaning out of it. Now comes the next part. We have got data, we have got information. What do we do with these two things? First of all, human being is intelligent. As I told you, Industry 4.0 is going to have only 3 employees: a human being, a dog, and a robot. Can we make or can we transfer this intelligence, whatever we have got, into a system? Artificial intelligence is a field of data science, is a field of science where we try to mimic human intelligence. This is the superset which we are dealing with. A subset of artificial intelligence is called machine learning. Now, what is machine learning? Machine learning is a field where we are trying to convert the information that we have got into meaningful information. What is the difference between information and meaningful information? Let us say this is an apple. It's an information. Good. But if I replace the same sentence as this is a plastic apple, then I have got more information from it, and I can actually make a lot more sense that this is a plastic apple, which means I should not eat it. Now, all these machine learning models are basically done using statistics. Statistics is a very, very vast field which plays a critical role in machine learning. Now, what is deep learning after all? The first problem that I have in machine learning is I need to define the mathematical model. I need to understand the maths, which I find it difficult to understand at this age. What if we let the computer do the math itself? These days, you will be surprised that there are machine learning algorithms, rather deep learning algorithms, to write poetries, to write short stories. Most of the short stories which are written these days You never know. It could be a computer which actually wrote this entire story. If you take a film song, 10% of the film song is recorded. 90% of the film song is augmented or updated using computer vision and speech recognition and audio transformations, where they convert a person's voice into whatever different they want. Computers are able to do all these days. This is a very, very important slide, and I want everybody to understand this because there's a big confusion outside. If I just ask 10 people, what do you mean by data science? What is machine learning? How it is different from deep learning? Be rest assured you will get 100 different answers. Data science is a field of science which deals with raw data. It just deals with data gathering, data cleanup, data manipulation, and trying to get basic insights of the data. If you look at this sensor that we dealt with, it is just like a level sensor giving you a value. Machine learning is a layer on top of data science. It is a combination of data and inferences from the data. There are three types: unsupervised, supervised, and reinforcement learning. I'm not getting into the details of machine learning because that itself is a separate talk in itself. Deep learning, it's a specific branch of machine learning which deals with neural networks or self-learning modules. Look, initially we had data, raw data. It was converted into meaningful information using machine learning. The raw data can also be converted into meaningful information using deep learning. Now, artificial intelligence is a big umbrella. It is a superset which actually covers deep learning, machine learning, and data science. And the aim of artificial intelligence is to mimic what a human being does. Okay. Since I told this is a very, very important differentiation that we have, you can also expect some interesting questions in your exam that you're going to write on Friday. I'm just leaking out some questions. This is a very, very important topic for you to understand. Now, let us take a case study and try to go into what is the role of smart sensors with respect to Industry 4.0. Let's try to understand it one by one. Digital twin. First of all, when we look at this photo, what do we really see? We see identical twins, two children who look exactly alike. Can I replace a sensor with something mathematical which looks exactly like a digital twin, or which is exactly identical to your vehicle speed sensor? This concept of introducing a digital replica of a living or non-living physical entity by bridging the physical and virtual world is called a digital twin. I know this definition is quite a complicated definition. Let's make it very, very simple. If I am able to replace this vehicle speed sensor with a mathematical model, then I call this mathematical model as a twin of this vehicle speed sensor. Okay, so digital twins are the first things that we need to do when we enter Industry 4.0. Why we are actually doing digital twin? Let's take a classic example. I told you that we are doing distributed development across multiple locations, right? Only at one place you might have a real sensor which is sensing the raw data. What happens to the other places? Transferring every data to every other person might be a very costly affair. Can I implement or can I mimic that sensor using a mathematical model? Run that particular model, compare the output that I have got with respect to a vehicle speed sensor and see my accuracies. If my accuracies are very, very close to the vehicle speed sensor that I have got, then I can call this mathematical model as a digital twin. What happens in digital twins? Basically, we are trying to replicate a functionality produced by a sensor. Now look, slowly we are migrating from a dumb sensor into something more software-ish. We are looking into a mathematical model that can physically replace a sensor. I'm not saying that all the sensors in the world will be replaced by mathematical models, but these mathematical models can augment the sensor or can actually work in a positive direction to make the information that we get from the sensor more valuable. Or rather, it is used to convert the data that we are getting into a very useful information. We can also call that as gold. Now, what are the applications of digital twins? There are several applications of digital twins. In manufacturing industry, typically, when we are having to produce different products which are distributed across multiple locations, can we replace as many sensors as we got with a digital twin? In automobiles, can we use a digital twin as a redundant safety mechanism to check or cross-check whether the safety of the system is not compromised? In wind turbines, we use digital twins to monitor and control the turbine in the farm. Why this is so useful? If I am able to have a mathematical model running at my headquarters, I physically don't need to go. I physically don't need to go to a plant, or I don't need to go to the windmill to see what's really happening. My mathematical model is actually telling what's really going on in the windmill, which is a few hundred kilometers away. This is the advantage of digital twins. Now, why do we use digital twins? And why are we able to use digital twins these days? Because we have got high compute system. We are having processors which are able to do heavy lifting. We can run a complex mathematical model in seconds using the modern day processors. In the past, we used to speak of million instructions per second. Okay, it is called as MIPS. How many MIPS does this particular processor actually handle? Now MIPS is gone. We don't use MIPS at all. We use a new word called flops or T flops. How many trillion floating point instructions can be executed in a second? Look, from million, we have gone already to trillion, indicating that the processor is so capable of actually handling the entire situation. Given that a processor is capable of handling such a situation, we can very well deploy digital twins to help us do our work better. Next challenge that we have got in Industry 4.0, I told you that we are going to have man and mission interaction. Let us look at a small video to understand how this man and mission interact together. So let me share a short video for a minute and then let's proceed. I hope you saw this video and liked this video. There were many very interesting things that you should have observed. First, let me tell you about this KUKA robot. Okay, this is from a company called KUKA. It's a German robot. And trust me, this robot is so powerful, it works on pneumatic systems. Okay, first of all, we know that any pneumatic or hydraulic equipment actually can lift, or it can lift very heavy weights, just like how we have in a crane. And the human being was working so close with the robot. In one instant, this lady kept her hand. The robot identified that it's not an object that I need to actually press, and it did not go ahead and press it. Trust me, had the robot failed there, this lady's hand would have been cut into several pieces. We all know how powerful pneumatic systems are and how much power they have to actually crush systems. If somebody needs to work with a robot like this, first of all, the robot should be working in the most safest environment. You cannot expect a mistake to be done by this robot. If the robot does a mistake, it is certain, underline certain, the person's life would have gone, or person would have got an irreparable injury. Okay, so when we say irreparable injury, let's say 4 of the fingers of this lady are cut. She cannot work anymore in her life. This is what is called as cobot. And what is cobot? It is called as collaborative robot. The lady was working so closely with the robot was working so closely with the human being, and when she was giving specific instructions to the robot, like for example, pushing it away, it understood that, I'm not supposed to interfere. This lady is doing something serious. I need to go back and wait. And the moment the lady finished her work, it resumed the work where it left. That is a very important thing. It cannot say that, what, I don't know where I am. I need to start from beginning and let me go to coordinate 0, 0. It didn't do that. It knew exactly what it need to do, and it continued from where it left. Second thing, when we saw the pin getting inserted, this lady pushed the pin a little bit to the left or to the right, whatever. The robot identified that there is a problem in this particular situation. If I press it hard, I'm going to break it. It took a supervisory decision not to go ahead and apply pressure. It was not told by the human being after all. So you look, when we are having distributed development, you are having multiple people working in tandem. There was another classical example that we saw of a potential loss of life for a person. Imagine when this robot was actually carrying the entire engine cabinet and it came very close to the human being. It stopped. The beauty is it stopped exactly at the position for the person to insert that rod, whatever he had in his hand. Had it come a few centimeters more, trust me, the person would have become a past tense. He would have been killed by this episode. This is exactly what we are dealing with in Industry 4.0. Collaboration, distributed development, supervisory decisions taken at local headquarters, man and machine working together in harmony. These are the challenges that we have got. Now, let us look at the most dangerous problem that we have got in Industry 4.0. Of course, I will not be spending too much of time on cybersecurity, as we will all think that this is a computer science topic, and being an instrumentation or a control engineer, I don't need to worry about it. Absolutely, this is a wrong statement, because we cannot work in isolation. You cannot say that I am an instrumentation engineer and I will only look at a valve. That is not going to help, because the valve is not a valve anymore. It's a smart actuator. And you need to know how to play with the software in order to get it to work. You need to know the domain that you're working with. You need to know the hardware that you're working with, and you need to know the software that is present inside the hardware. Okay, let's look at cybersecurity and why it is such a big risk. First of all, we told that you have got a headquarters where the data is transmitted. What if the data cannot receive or reach the headquarters? Somebody is doing a denial of service attack. If the information doesn't go to the headquarters at all, what happens? Supervisory decisions cannot be taken. And we told that there are three people: man, dog, and a robot. If the man is frustrated playing with the dog, he goes and starts playing games in the computer. And when he plays games in the computer, he can get attacked by a virus. He clicks a link which he is not supposed to click, and that's it. His system is infected. If his system is infected, his control system is actually infected. Decisions can be taken in a very, very wrong way. There is a classical example where we have all read it in the newspapers long ago, where a person was able to get control of a Ford car just by looking at the CAN data packets that were going. He was able to sniff those packets, manipulate those packets, and make the brake sensor not work. This is the challenge that we have got. What are the challenges that we need to deal with? Denial of service attack, malware attack, man in the middle attack. These are all reasonably easy attacks that we have. There is one of the most dangerous attack. If this is an organization where we have employees, we have one antisocial element who is also an employee, and this person is called as an insider attack. A person who is working in the organization and who has bad intentions. If he gets access to the system, then he can create havoc in the system. How can we actually get into an insider attack? Somebody compromised their user credentials. Somebody left their system unlocked and walked out.
Same thing happened in the first day session, sir. Inaugural session. What you are telling, that
Okay,
is what one person entered and disturbed the function. Okay, thank you. Okay,
excellent.
continue.
This is a classic example where now let's say, how did this person get into this entire system and disturb the session? He knew that there is an FDP program going on. He knew this is the link to actually get in. And he knew that if I get into the system, request annotation permissions, go and scribble whatever I want on the screen and create confusion to all the participants. This is an insider attack.
Same thing. What you are telling, that is happened in the first day inaugural session. He taken control, all control of host, even mute, unmute, everything is taken control. Thank you, sir.
Exactly. Exactly. And you might have observed during this entire session, during the inaugural session, when you are actually so serious about inaugurating a function, somebody comes and takes over control, your entire system is jeopardized. You are totally ruined. You do not know what to do. Your confidence level has gone down. All of a sudden, a dream which you had to actually conduct this FTP in a very colorful way suddenly starts crumbling in front of your eyes. And look, if the person's confidence drops, trust me, the entire system will crash in a few seconds. This is the most dangerous attack that we need to deal with, and those attacks are called insider attacks. How do we know whether a person is a genuine person or not? We cannot decide. I cannot say whether Srikanth is a genuine person sitting on the call or not. The only way we can actually control an insider attack is not tell everything to everybody. If Srikanth needs to know that there exists a link and he needs to click this link to join the meeting, somebody else will make him a presenter and he presents the information. That's all he needs to know. He need not go and know how to actually hack into the system, or he need not know what is the user ID and password of the person who has got this Cisco WebEx account. This is what everybody need to do when they are actually implementing any system. In Industry 4.0 scenario or the context, insider attacks are the most dangerous attacks, even though we have told that data is distributed present across multiple sites. We are getting into one problem where one person does not know all, he is dependent on the other, and he is dependent on distributed development. That is the first challenge that we need to deal with. Now, how do we deal with such insider attacks? What are the ways in which not only insider attacks, What are the ways in which we need to look at and protect our system? Threat modeling is the first and foremost tool that we need to use. Now you look from an instrumentation engineer who is actually working in a process plant. We are working closely with a computer science graduate who is trying to identify what are the attack vectors that are possible. We are telling him, we are sitting with the computer science engineer and we are telling him that this is a plant, this is what it does, these are the sensors, it has got Ethernet, it has got Wi-Fi, and it has got Zigbee. Now the computer science engineer will think, where is the trust boundary? What happens if somebody hacks the Ethernet? What happens if they send a very high fuel level or level sensor instead of a low level sensor? Tries to manipulate the data. The instrumentation engineer and the computer science engineer sit together, debate and discuss to come up with the threat model. Now look, the computer science engineer alone cannot do this threat model. Instrumentation engineer alone cannot do this threat model. They need to work together. And that is also an important concept in Industry 4.0. Working in distributed way, working together as cyber physical systems. We never need to sit close to the computer science engineer. He can be somewhere in America and we can be sitting here and actually helping him out. This is the most important thing that we need to take care. Now let's try to summarize all what we have learned in this entire session and try to see what we got. We have got another 15 minutes, so I will try to wrap up in a couple of minutes so that we have a good amount of time for some question and answers. So first thing, we all know that we are heading in a very, very fast rate. The world is going from downloads in millions, which is taking 75 years in the past, to few hours right now. It is growing at a very, very fast rate. Data is the prime mover. Everything is data. How do we convert data into information is what is going to decide the future. Machine learning and deep learning are the topics that's going to dominate our life. Ultimately, maybe in another 20 years, we will have three people in a company, a dog, a human being, and a robot. Now, given that we have got all these, as a faculty member, as a teacher, as a student, what do I need to do? Can I survive in this world if I do not know certain things? Things will become difficult. Trust me, we have gone through this right now during this lockdown. I have personally helped out so many teachers in schools who are not able to understand the concept of online teaching. I really had to go sit with them, explain them how to use WebEx, explain them how to share a screen. Trust me, I did this to more than 50 school teachers across Bangalore in order to help them teach the students. Unless they upscale themselves, they will become redundant in this world. What are the things that we need to upscale ourselves? Many things. Python, TensorFlow, Pandas, OpenVINO, NumPy, Minitab, MATLAB. All these tools and techniques are available for us. There is a lot of help available on the internet. Why these tools and techniques are there? To convert data into information. Otherwise, data as a data alone is as good as mud. Let's all work towards this particular approach and upscale ourselves. I have set a syllabus for Malnad College of Engineering. As a Board of Studies member, I set a syllabus for Industry 4.0. What are the topics that a student needs to learn in their final year engineering as an elective subject so that they are ready to deal with such challenges in the future. Now, let's stop the session. I have been speaking so much for so long. It was a monologue. I would like to open up for questions. Any question that you have related to this topic or anything which is bothering your mind, please feel free to ask the question. I will try to answer it based on the limited knowledge I have got.
Yes, sir. Thank you. One more basic question from Ranjan Thakur. What is the basic difference among sensor, transducers, and actuators?
Sure. Now, what is a sensor? Sensor is the lowest level, or you can consider it as a basement level of a particular system. Let's take an example of a level sensor. A sensor is something that senses the level of water present in a tank. Transducer is a device which converts this information. It could be voltage, it could be current, it could be 4 to 20 milliamps. It converts this information into something that can be read by a microcontroller. For example, any voltage which is converted or noise removed by an instrumentation amplifier as an output of the sensor is the transducer. It is converting something from a given language to a language which is understood by a microcontroller. Actuator. What is an actuator? An actuator is a final control element which actually drives the valve. Having a sensor is useless unless we are able to drive something. There is no fun in knowing what is the water level in my tank unless I am able to fill the tank or empty the tank. Actuators are the outputs. Sensors are the inputs. Transducer comes in between, which converts an input coming from a sensor into a meaningful form which can be understood by a microcontroller or a processor. This is the basic difference. Now, if we add the word smart sensor and a smart actuator, it changes the entire context. A smart sensor is a sensor which not only knows what is the raw data that it is reading or receiving, it is also able to convert the data into information to whatever level it can.
Yes, sir. One more question.
Yes, sir.
Hello.
Yes, sir. Please go ahead.
Which branch have set the syllabus for Industry 4.0?
Instrumentation and technology, sir.
Instrumentation. One more question is there, sir. How can we equip with Industry 4.0?
So first of all, there is something very useful information that I would like to share. Let me open the internet and show it to you. There is something called AI for all. Okay. And this is an initiative done by Niti Aayog. Okay. In the past, you might have all learned about, the 5-year plans, right? This has been converted into something known as Niti Aayog, where they come up with a vision. And this vision, this discussion paper is posted by the Government of India. It is a 115-page document which says what is the role of artificial intelligence in future India. Okay. This particular paper gives you very good topics. Let's just go through this paper in a very brief way. These are the broad areas where artificial intelligence is going to take over. Healthcare, agriculture, education, smart cities, smart mobility and transport. Now you look in all of these topics, they have added the word smart. Everything is going to be smart. And this entire discussion paper actually speaks about how this artificial intelligence, machine learning and deep learning is actually going to take shape, or it's going to give a future for India. Now, just giving something about artificial intelligence and saying that it's something very good is not a great idea. What has the Government of India done? Airavat. This is another platform which the Government of India has proposed, and it is actually setting it up. What is this? This is an artificial intelligence based cloud computing infrastructure for any citizen in India. Any citizen in India should be able to access high compute power. What if I need a computer which is having, say, for example, 10 trillion floating point instructions per second? Obviously, I cannot go and purchase a particular computer and do it. Look here. There are multiple systems which have, for example, this system can run 148 trillion floating point instructions per second. These servers are going to be available for any citizen of India. Anybody who really wants to do any research, anything on this particular data science can actually go onto the server, create an account for himself and utilize these services for free or by paying a minimal charge. Third thing that we might ask for all these, I need data. Where do I go? Excellent. That's the next thing which Government of India has done. OGD framework. This is another called as another initiative of the Government of India called as Open Government Data. This is a website which is accessible to any citizen in the world where they post data from real world situations. For example, if I want a data of how much crowd exists in Qutub Minar on a weekday or on a weekend, if I want information like that, I can go to this open source information, pick up the data that I specifically need. There is one more very interesting website called India Statistics. This particular website is from the Ministry of Human Resources. I don't know whether it's human resources. It's the education department, whichever ministry it belongs to, where they offer data in the form of indiastat.com. This is a website where you can get all the information that you need. For example, if you need information on agriculture, just go to agriculture site and then you can look at specific data related to how many worms or germs are affecting a particular plantation. If you take rice as a plantation, what is the data that we have got to say that it has been infected by this particular virus or this particular bacteria? You get all this information available in this website. There is also one more important point. This website is charged and you can get the data downloaded on your computer by paying a small fees. There is also a lot of information which is available in India Stats for free, which you can download and analyze. So how do you equip yourself? The Government of India is creating a framework for you to equip yourself. The first thing what they did is created a discussion paper. This is a very interesting paper. I would recommend everybody to actually go through this. The content in this is so detailed and they give you use cases where they can implement these concepts. Second thing is the iRawat platform, which gives you an infrastructure to implement what you need. And the third thing is the data sets in order to help you to implement what you need. Now, they have given you rice, they have given you dal, and they have given you fire. The only thing that you need to do is put all these things together and make a beautiful meal and enjoy it. This
Okay,
is the
sir.
way we need to equip ourselves. Yes, sir. Please.
Okay, sir. Oh, so what are the books, resources to get more information on this topic? Already you've given the resources. What are the books?
Yes, sir. This is a very important topic. Again, there is a book in Springer by this author. I might not be able to pronounce his name quite well. His second name is Gilchrist.
Alas, the Gilchrist. Yeah.
Industry 4.0 by Gilchrist. This is a very good book which covers all the details right from the scratch to the advanced concept. Now, people or colleges or institutes which have got access to Springer, they can download this book ebook free from the internet. Okay. For example, Amrita School of Engineering has got access to Springer and I am able to download this book free. Please be aware that there are copyright issues. So when you are downloading books, take note of those copyright issues when you're sharing data across with colleagues.
Okay, sir. One more question. We can apply Industry 4.0 in smart grids.
Absolutely. So let's look at what. Okay, I have just closed that website. In fact, one of the website in the discussion paper which I actually spoke about, written by Government of India, there is a talk specifically on smart grids, where they say how you can make it's a part of smart city initiative, where a smart city has got multiple things: smart transportation, smart security, smart infrastructure, and smart grids, so that we can conserve the energy and utilize it in the best possible way so that everybody gets benefited. It comes under the topic of smart cities.
Now, participants can unmute themselves. They can ask directly question to the Shrikant sir. Yes? No questions? Okay, sir. Hello.
Thank you so much, sir.
Shrikant sir. One more, your junior is asking that you are senior to him from, I think, 1 second, sir. In the, what is that?
Oh,
His name is Gopi Krishna Rao. Hello.
He was my senior in
No, no,
Malnad
no.
College of Engineering.
You are his senior.
Oh, is it okay?
And also, Tuesday session, your sir, Suresh Babu sir,
Suresh Babu
session
sir.
was there. Yeah. Thank you, sir, for
I would
bringing
like
us.
to just add one small statement here before
Yeah,
I conclude. First of all, what I am today is not because of the knowledge that I have gained by reading so many things. There are a few role models who have actually made me what I am today. I would like to specifically thank Suresh Babu sir, Shiv Kumar sir, and Mohan sir, and Meenakshi madam, who are all my teachers in Malnad College of Engineering. Especially Suresh Babu sir, he used to make power systems. We had power electronics as a subject. He was a teacher for that subject. He made the topic so interesting that it made me really work in a field. Although I am an instrumentation engineer, I might I am not working a lot in software. I am working very, very close to instrumentation systems. This is because I was inspired a lot by four or five faculty in Malnad College of Engineering. Suresh Babu sir, Mohan sir, who was the HOD at that time, Meenakshi ma'am, Narasimhan sir, and Shivkumar sir. They actually made me think that instrumentation is not a very silly subject. It's a very useful subject, and actually it can be used to do wonders. So I would like to thank my teachers for making me what I am today. Thank you, sirs.
thank you, sir. Thank you, sir. Thank you. Uh, Thank you, sir. Bringing from our childhood to Industry 4.0 to what happened in our childhood, what happening nowadays. Because in depth event and telling that one. Actually, in the inaugural session, we have faced it. What you are telling that one, some unauthorized person entering and disturbing the session. That is what cyber security you have to learn more. And in depth event in the Industry 4.0 from the atom level to the top level. It means that I rise the sensor level to the control level.
Yes, sir. Feel free, sir, if anybody has any questions and they need to reach out to me, they can always reach out to me. My email address is available. They can write me an email. They can contact me. Whatever little I know, I'm very happy to share with others.
Yeah, definitely, sir. We'll do that one. Thank you for your wonderful session, sir. On behalf of Department of Electrical Engineering UVC, I'll heartful thank to you, sir.
Sir,
Thank you so much.
Thanks.
sir,
Yeah, Maheshan?
one of your email ID, sir.
So my email ID is, I will just write it here. Let me just quickly write it here. I hope this will be visible.
Yeah, sir.
My
Visible.
email ID is srikanthks@gmail.com. This is
And
my email address. You can feel free to reach out.
and one more thing, Shrikant
Yes,
sir
sir.
is the rank holder from the MCA Asan. We are very privileged to have such a wonderful person in our 5 days workshop. Thank you, sir.
Thank you very much, sir.
Thank you very much.
Thank you all. Have a great day ahead.
Thank you, sir.
Goodbye.
Bye, sir. Maheshan, KPS, madam.
Shall
Hello.
we close? Shall we close the meeting?
Yeah, shall we close? Yeah. 1 second before closing the meeting, I request all participants to join 225, and we need your video for the in that sessions we have to post to our ATAL portal. Please come to video in the third session of this today. Please come to video for a 1 or 2 minute. We'll take some snaps and later you can stop the video. Please. Okay. 225 you can join.
Hello.
Hello.
Can you take photo tomorrow, sir?
If anybody interested today, if you come, today come, tomorrow also we can
Today
take
is Thursday, and I don't make a shave over actually.
Okay. Okay. Madam Nalini, madam, you want to tell anything, madam?
Nothing, sir.
Nalini, madam.
Nothing.
Please unmute yourself because madam came to video. Madam, hello. Nalini, madam, you want to say something? Hello. Nalini, madam, unmute yourself and say something. Madam already came to video. Yes. Okay. Okay, KPS and Maheshan will end the sessions. We'll 225 will join. Okay, thank you.
Okay.